Artificial intelligence can look mysterious from the outside, but beneath the big name it rests on three simple ideas: data, algorithms, and learning. Once you grasp these, you already understand the core science behind AI. In this lecture, we open the black box using examples from schools, markets, and hospitals so that students, teachers, and curious minds can see how machines learn. Begin with data. Data is simply information collected from the world. In a classroom, test scores and attendance records are data. In a market, daily sales and prices are data. In a hospital, blood test results and temperature readings are data. Computers can now examine millions of such records quickly and detect patterns that human eyes would miss. Next come algorithms. An algorithm is a step-by-step method for solving a problem, like a recipe for cooking jollof rice or the procedure for long division. In AI, algorithms tell the computer how to move through data, test ideas, measure errors, and adjust its guesses. You do not have to fear the word. It simply means organized logic written in a form a computer can follow. When we combine data and algorithms, we get machine learning. Instead of programming the final answer directly, we show the computer many examples and let it discover a rule. Imagine a teacher who wants to predict which students will pass an exam. She studies attendance, continuous assessment, and pass scores. A machine learning model does something similar. We feed it student records and label who passed and who failed. The model adjusts its rules until it finds a pattern that predicts success. After training, new student data can be used to estimate the likely outcome. Deep learning is a more advanced form of machine learning that uses structures called neural networks. The name comes from the human brain, which contains billions of connected neurons. A deep learning model has layers of artificial neurons that pass signals forward, adjusting their connections until the model recognizes patterns such as shapes, sounds, or words. Consider malaria detection. Traditionally, a lab scientist looks at blood slides under a microscope, searching for infected red blood cells. With deep learning, we take thousands of labeled images, some with malaria, some without, and feed them into a neural network. At first, the model guesses almost randomly, but each time it is wrong, it receives a correction. Over many rounds, it learns to spot the visual patterns that signal infection and becomes fast and fairly accurate, serving as an assistant to the human expert, especially where staff are few. The same learning idea appears in many sectors. In finance, models learn from past transactions which ones look fraudulent. In agriculture, they learn from images which crops are healthy and which show disease. In education, they learn from e-learning records which topics are difficult and which learners may drop out. In every case, the cycle is the same: collect data, choose an algorithm, train a model, test it, and then use it carefully in the real world. It is important to see that machine learning does not produce perfect wisdom. If the data is biased, noisy, or incomplete, the model will learn biased, noisy, or incomplete patterns. If past records favored one group unfairly, the AI may repeat the same injustice. That is why human judgment and ethics remain central. Teachers, doctors, bankers, and policymakers must ask, what data are we using? Who is missing from it? And how might the results affect people's lives? For learners in Africa, the good news is that you do not need to become a full-time programmer to engage with these ideas. Start by thinking critically about data in your own environment. How could your school, clinic, farm, church, or business keep cleaner records? What questions would you want a machine to answer if it could learn from that information? Once you have meaningful questions and good data, tools and collaborators can handle the technical work. In summary, the science behind AI is not a secret reserved for foreign experts. It is built from everyday ingredients, information from the real world, clear procedures for handling that information, and systems that improve as they see more examples. When we demystify these steps, we gain the confidence to use AI wisely, to question it when necessary, and to imagine local solutions powered by our own data and creativity. Please like, share, comment, and subscribe. Thank you for listening.